A small ball moving with velocity 9 meter per second collide with identical ball at rest. This means M1, M2 is M. U1 is 9 meter per second. U2 at rest. This is M. This is U1. This is M. U2 0. Such that direction of each ball makes 30 degree with original line. This is V1. This is V2. Thirty degree. It is V1 cos 30. It is V2 cos 30. Resolve this. It is V2 sin 30. It is V1 sin 30. A small ball with this collide with identical ball at rest, such that direction of each ball makes angle 30 degree with original line. After impact, after collision, find the speed after collision. From figure, V1 sin 30 is V2 sin 30. This is V1 sin 30, V2 sin 30, equal and opposite. Therefore, V1 is equal to V2. Now, law of conservation of momentum. M U1 M0. This is momentum before collision. M V1 cos 30, M V2 cos 30. This is momentum after. M goes with M. This is U1. It is 2V1 cos 30. Why? V1 is equal to V2. V1 to be find out. U1 2 cos 30. U1 is 9 meter per second. It is 2 cos 30 root 3 by 2. It is 9 root 3. Or V1 9 multiply by root 3 divided by root 3. It is 3 root 3. It is what? 1.732 6 9 1 5 meter per second, and it is also v2. So this is velocity after collision. Show bodies exchange their velocities after collision if masses equal. Find coefficient of restitution, collision being elastic. We have done it already in special case. Now directly this is M U1, this is M U2, this is before impact. This is impact collision. This is position after collision. After impact. According to law of conservation of momentum, mu1 momentum of this plus mu2 momentum of this, total momentum before impact, before collision is what? mv1 plus mv2 or u1 minus v1, v2 minus u2 first. According to law of conservation of kinetic energy before before impact kinetic energy, after impact kinetic energy, half 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 m, common cancel out, u1 square minus, take v1 this side, v2 square second dividing second by first, u1 square v1 square, u1 minus v1, this was u1 square, this was u2 square, u2, take u2 this side, v2 square, u2 square, v2, u2, it comes out to be u1 plus v1, v2 plus u2. Number third, v2 u1 v1 minus u2, putting this value in first. This was first, u1 minus v1, v2, this is v2, u1 plus v1 minus u2 minus u2, take v1 to this side, 2v1, u1 with u1, it is 2u2, or v1 is u2, similarly v2 is u1, fourth, fifth. This was velocity of second body after collision, this is velocity of first body. This was velocity of first body after collision, it is velocity of second body, that is bodies exchange velocities after collision if mass is equal. Also E, V2 minus V1, U2 minus U1. What is V2? It is U1. It was U1 minus U2. What is V2? It is U1. What is V1? It was U2. U1 minus U2. And it comes out to be what? 1. Elastic collision shows coefficient of restitution should be 1. two identical ball bearings are at rest. ये two, number 3, two balls bearings identical means mass is same, are at rest and are in contact with each other. They are in contact and at rest. Another identical is incident. Another identical, a number first, is incident on them as shown. This means with the velocity it is incident. They are on frictionless table, no friction is there. Which result is possible? This is the first result, this is second, this is third. Which result is possible? This is the question. Now let mass of each ball bearing. The collision between ball bearings is what? Elastic. So kinetic energy before and after should be same. Kinetic energy before impact this is half mv square, this is 2m v square, it is half mv square. Why? Velocity is 0, mass m plus m, 2m. First case, kinetic energy after impact. First case, it is half m0. It is half 2m. Mass is 2m, v is v by 2. So it is v square by 4. Half with half, so it is 1 by 4 v square, mv square. That is kinetic energy not conserved. So this result not possible. Second case, kinetic energy after impact. It is equal to, this is second case, 2m kinetic energy half into mass is 2m, velocity is 0, plus half mv square. It is half mv square. Equation third. This was kinetic energy before, this was hence kinetic energy conserved. So this result is possible. Third case. Kinetic energy after impact. Third case. This is third case. Half m. This is m. M plus m plus n into v square. Half mv square. It is 1 by 6. 336 mv square. Compare with first. Kinetic energy not conserved. So, this result not possible. Another numerical, a body of mass 2 kg make elastic collision on a body at rest. And continues to move in same direction with 1/3 of its original speed. Calculate mass of other body. This is M1, this is U1, this is M2, this is U2, and it is at rest. This is M1, M2, impact. This is M1, V1. This is M2, V2. After impact, before impact. Here M1 2 kg, M2 to be calculated, U2 0 and V1 1/3 U1. About V2 we don't know anything. Now V1 is what? M1 minus M2, M1 plus M2, U1 2M2, M1 plus M2, U2. V1. What is V1? 1/3 U1. M1. M1 is 2. M2. We have to find, it is 2. M2 we have to find U1 is U1 plus, as U2 is 0, so all is 0, U2 0. It was U1, U1 cancels with U1. Cross multiply. 1/3 U1 is equal to, now cross multiply, U1 goes with this U1, 2M2 it is 2 plus M2, it is 6 minus 3M2, it is 4M2 is 8, therefore M2 is 2 kg. Again 4, not 8, it is 4. 6 minus 2, so M2 is 1 kg. Another question. This is a bob. Connected to a string. A. This is another bob. B. Identical. To identical bobs. A and B as shown. Bob A is released. It makes elastic collision with Bob B at rest. At what height Bob A will rise after collision? This is a question. Bodies will exchange velocities after collision as masses are equal. So A will come to rest and will not rise at all. And B moves in horizontal direction. ये कोई वायर नहीं है यहाँ ये. This B is free to move. This is point of suspension direction.